Central tendency is the first measure of these statistics that we'll be using in this course. Variability is the second. Sometimes it's called the second moment of central tendency, but variability tells us something about not just where the middle of the distribution is, but how much variation there is in the distribution. Do we get all the information that we need to know from just the average? So for example, if I told you that two stocks had an average return of, say, 20%, is that enough information for you to say, well, happy to invest in either one? No, you'd want to know something about the variability of your expected returns. And we can see in this diagram that stock A has a very tight distribution. Let's say that the lowest here on this end is 5%, the upper end is 35%. Stock B has a much more variable return. So we've got a low here of, say, a negative 20% and a high here of 60%. Now that means something, doesn't it? Because just because both of them have the same average, you want to know more than just the average. You'd like to know how much variability, and sometimes in finance we call this variability risk. It's also termed as unreliability, or differences among items in the sample. How do we measure the variability? There's several measures that we can use. The first measure, it would be the range. We take the largest value and we subtract the smallest value, and the difference between the largest and the smallest is our range. It only tells us the overall spread. It doesn't tell us anything about clustering. It's very unstable, extremely affected by outliers. And in the stock example, they have the same range but different patterns of variability. So why is it used? Because it's easy. Everybody understands it. Even elementary school students understand what the range means. A more common and more useful measure of variability is the variance or the standard deviation. Now, this is a very important part that we want to recognize in this course, that the variance and the standard deviation are essentially the same thing. In fact, the variance is just the standard deviation squared. So in a problem, in say a homework problem or a test problem, I may give you the standard deviation or I may give you the variance, and you need to recognize that the variance is different from the standard deviation but is essentially the same measure. It's just transformed by this exponent. How do we measure the variance? We'll be measuring variance in the class explicitly. We'll be doing it by hand at first, but then rely on the computer to do it for us. But we want to make sure that we understand what the measure of variance is doing. And the measure of variance is given by this equation here. Once again, we see the sum sign, but this time, instead of adding up all of the observations like we do in the mean, we add up all of the squared differences. So xi is each observation, and x bar is the average observation. So for example, let's say that the average height of male individuals is 69 inches, and you are, for example, 72 inches. So your difference would be 72 minus 69, or 3 inches. So we would take every difference and we would square it. And we square it because if we had a symmetric distribution, our variance would be 0. The positives would offset the negatives, but when we square the differences, then anything squared, whether it's positive or negative, would give us a positive number. After we've squared the differences and added all of the differences up, we take the average difference, or the average deviation from the mean. Just like when we were measuring the mean, we divide by the number of observations. This is the variance. The variance is given by the Greek symbol s, lower s, squared. This symbol is called sigma, and you'll see this quite often in my notes. That's the population variance. Sometimes the sample variance is given. This is just an English letter S squared. So if we want to know the standard deviation, we take the variance and we take the square root, and that gives us the standard deviation. Now, why do we want to know the standard deviation instead of the variance? Why, if they're the same thing, why not just use the variance? Why go through the extra step? The nice thing, and probably the most important thing about the standard deviation, is it will be in the same units. It will be in the same units as the mean. So for example, if in my height example, if the units were in the number of inches, then the standard deviation will also be in the number of inches. Whereas the variation or the variance would be in inches squared. And that's not an area, it's just that it's the height squared. Another important difference is that the difference between sample statistics and population statistics. And I've put in a note here, but please recognize that in this course we're not going to discuss so much the differences, but just to recognize that the n in a sample statistics would be n minus 1. If you want to know more about that, you can Google it or you can look at a textbook, but we won't be discussing it so much in this class. In the next few pages in my notes, I go over a data set that we'll be discussing in great detail called the Antec case. We're going to spend a lot of time. I used to have these notes described in these video lectures, but I found that it's much more helpful if we really dive into this data set and we use this data set to measure the mean, the median, the mode, the variance, and standard deviation, and then use that information to make some inferences or interpretations.